Okay, in this video, we are talking about two-way tables, Venn diagrams, and probability. So you'll be either working with two-way tables or Venn diagrams or just with randomly mentioned word problems. So a hospital tracked the day of the week each baby was born and whether or not the delivery was scheduled in advance. The following two-way table displays the data for the sample of babies born in a particular year at the hospital. So we have date of birth. So we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and we have the total of the scheduled, unscheduled, and the grand total of 500 total births during that year happening Sunday through Saturday. So is this sample, in the sample, are the events Tuesday and Friday mutually exclusive? Well, mutually exclusive means that they cannot happen at same time. So Tuesday and Friday are completely different days. Those births obviously cannot happen at the same time. So yes, this is mutually exclusive. So we are going to select yes for that question, and I'm going to just erase that just so because we need to move down. We are dealing with 500 total. That's what it was there. Now, find the probability that a randomly selected baby from this sample was born on Tuesday or Friday. So since we are mutually exclusive and they don't intertwine, we do not have to do that probability of Tuesday plus the probability of Friday and then subtract the probability of Tuesday and Friday because they don't happen at the same time. They're mutually exclusive. So here we just want the probability of Tuesday, which is 90 out of 500, which equals 0.18, and the probability of Friday births, which is 70 out of 500, which equals 0.14. So if we were to take those two and add them up, we end up with the probability of Tuesday or Friday is 0.32. So we're going to take that and plug that in. Hopefully we have enough time to work on another one, 0.32. And we are correct. Let's try another one to see if we can get full understanding. Okay, here we have a Venn diagram. So notice we have some things that are overlapping. So might be mutually exclusive or might not. Most likely might not because all of these are intertwined in some way, shape, or form. So a business owner noted that the features of 100 cars parked in the at the business. Wow, I can't speak. Here are the results. So here's your Venn diagram. We have the sunroof, two-door, four-door. So cars with the sunroof, cars with two doors, cars with four doors. In this sample are the events two-door and four-door mutually exclusive. No, they are not because they do intertwine. However, there are none that work here. No, I didn't notice that they were both 0. So in this case, they may be mutually exclusive. Okay, we'll check that out in a little bit. Might be wrong, but I believe that I'm right because they don't intertwine each other. They intertwine with the sunroof, but not with each other, two-door and four-door. So find the probability that a randomly selected car from this sample has two doors and four doors. So we have the probability of two doors. Let's see, we have how many? 100 cars, right? So probability of two doors would be 32 here. So that's probability of two doors, so 32 out of 100, so 0.32, plus four-door, which is 0.45, so that's 0.45 because that's out of 100. So we end up getting 0.77 would be our probability of two-door or four-door. So let's check ourselves here. So we have 0.77. I know that moved up, but we believe that they are mutually exclusive, and the probability is 0.77. Yep, and we are correct because they do, even though they overlap, they do not share anything in common. So that's why they would be considered mutually exclusive. But if we just had one number here, where there was just a 1 here or here that replaced those two zeros, then that would not be mutually exclusive, and you would have to do that whole bit where you would have to do the probability of two-door plus the probability of four-door, and then subtract the probability of a two-door and four-door. Okay, so that's just a little bit of two-way tables, Venn diagrams, and probability.